In this video, we're going to look at the mean value theorem. So the mean value theorem tells us if we have a continuous function defined on the interval between a and b here, and we've called this function f in blue here, there is a point c in between a and b where the slope of the tangent line, so this line here, is equal to the slope of the line through A and B, or the chord line. So this slope here, call it slope 1, and this one slope 2. These two slopes are equal. That is the mean value theorem. So there is one point C where that can occur, or there can be multiple points where that can occur, where the slope here is equal to the slope between A and B, drawn through those points. So we can say that the slope 1 is equal to the slope 2. Slope 1 is the derivative of the function, the first derivative of this function f at the point C, evaluated at that point C. So we can write it like this. Slope 2 is the average slope between A and B. So that is simply the function at B, take away the function at A. So this height from there to there, so this height here, divided by the horizontal distance between the points A and B. So B take away A. This is simply rise over run. So this here is the formula we use in most of our problems to do with the mean value theorem. And most commonly, we need to find this point C. So let's now take a look at an example. If we have the function f of x, which is equal to square root of x, which is equal to x to the power of a half. And in this example, we want to verify the conclusion of the mean value theorem for this function on the interval a, b, where a is greater than or equal to 0 and b is greater than a. We want to verify that there is a point C in between A and B where the tangent or the slope at that point C is equal to the slope of the chord line between A and B. So let's firstly write down the formula. The first derivative evaluated at C of the function is equal to the function evaluated at B, take away the function evaluated at A, divided by B take A. We know the derivative of this function. It is simply 1 over 2 the square root evaluated at C. The right hand side is the function evaluated at B, so that's the square root of B, take away the square root of A, over B take A. Now let's get everything in a square root sign to cancel out some of this stuff on the right hand side. So the bottom, well, firstly you write the top again, and the bottom can be written as the some factors that cancel out the top. So let's write the b take a as the square root of b, take away the square root of a, multiplied by the square root of b plus the square root of a. This is simply b take a if we were to multiply this out. But by doing this, we can cancel out this factor with this factor. So this is now written as 1 over the square root of b plus the square root of a. Now we need to solve for c, so we can multiply 2 times the square root of c up to the right and this one up to the left, and divide by 2 and take the square of both sides. We get c equals the square root of b plus the square root of a over 2 all squared. And we now need to show that this point c, this value here, is between the points a and b. So the point c has to be between a and b if the mean value theorem is to hold. Now, coming over here, b can be written as the square root of b plus the square root of b over 2 all squared, because two square roots of b, the 2's cancel out and the square root cancels out with the square and gives us back to b. And a can be written similarly, so we can write square root of a plus the square root of a divided by 2 squared. And we know that a is less than b and b is greater than a. So by comparing this value here with this value here, because b is greater than a, and we have two b's here, and the top line will make the whole value larger, we know that b has to be greater than c. And if we look at a here, a is smaller than b, so we know this whole value here on the right hand side is less than this value here, because a is smaller than b. So this proves the mean value theorem, that there is a point c where the slope of the tangent line at this point is equal to the slope between a and b. So we can write c is greater than a but is less than b.